So remember we talked about why do we need all these different forms? Seriously, like it's too many forms, too many different ways to write them. Why? And hopefully this will answer the why. So the first thing we're going to do is we're going to state the key features of each graph. Okay, we talked about key features before, and then it's coming up again. You need to know the key features. You need to be able to find them. So if I'm looking at the graph here, I'm just going to make the graph a little bit bigger so it's clearer. What would be your zeros?
-2, 0, and -1, 0.
Okay, so I'm just going to write them as x equals 2 and x equals -1. Okay, I'm going to forget about the point. I'm just going to write the two values.
Is that alright? Can I write that down in the stuff?
You can write it like this, or you can write it as this.
Thank you.
I'm okay with either, as I said earlier. Okay? What would be your y-intercept?
2.
It's about 2, but you have to say y equals 2. Or you can write it as 0, 2. Vertex is a little bit hard to spot, but let's look at, I think this is -1/4. And this is in between -1 and -2, so it's at -1.5. Okay? So what would your vertex be? Where would your axis of symmetry be? X equals 0.5. And then your optimal value? Let's look at the second graph. What are your x-intercepts? Or your zeros? It's 1. Yeah. So -3 and 1. And your y-intercept? Your vertex? -1 and what?
8. Oh.
No, it's 8.
Oh, it's 8.
-1 and 8. Okay? -1, 8. Yeah. So if you go back here, this is -2, this is -1. And then that means your axis of symmetry is x equals -1, and your optimal value, it's a max at y equals 8. So right now, I want you to compare your equation to your key features and tell me if there's any match. Opposite of what?
Vertex is opposite.
Vertex?
Or not the vertex is 0.
Okay, let's look at the equation. So the equation is y equals x plus 2 times x plus 1. So is there anything in the key feature that matches the equation? The zeros. How do they match? So the zeros here are x equals -2 and x equals -1, right? My equation is x plus 2 times x plus 1. Does it match also for the second equation? So they match, but what is the difference? It's the opposite sign. So do you think that's going to happen all the time? Yes, it is going to happen every single time. Your zeros, the factored form is going to help you find your zeros. is going to help you find your x-intercepts. And that's why we need the factored form. Okay? So if I look at the factored form, remember that your zeros is when y equals 0, correct? So your y is equal to 0, right? So if I have my equation, y equal x plus 2 times x plus 1, okay? Now, y is equal to 0. I'm looking for the zeros. I'm looking to solve my solution, right? And I'm looking for my zeros. So that means my y value is equal to 0. Okay? So I replace the y with 0. Now, something times something equal to 0. When would that happen? When a number is multiplied by a 0, you get 0. Okay? The only time you're going to get a 0 if you multiply this by a 0 or you multiply this by a 0. Right? So one of these brackets has to be a 0. When is this bracket equal to 0? Bring the 2 over, x equals negative 2. Right? When is this bracket equal to 0? Bring the 1 over, it becomes a negative 1. Did I get my zeros? Right? Because you're thinking about the zeros when y is equal to 0. That's why sometimes writing the point is important, because you can visualize. You can see that y is equal to 0. That means I am replacing that y by 0. And then the only time I can get a 0, 8 times what gives you 0? 8 times 0. 100 times what gives you 0? 0. So that means one of your factors, one of your brackets has to be a 0 in order for you to get a 0. So that's why we set the brackets equal to 0, and then we solve for our solution. We solve for our zeros. Right? Because once I write this, people are going to ask me, where did these numbers come from? Okay, now I can do the same thing for this one, right? I can set this equal to 0 because I'm looking for my zeros. And I can set x plus 3 equals 0, which means x equals negative 3. And I can set x minus 1 equal to 0, which means x equals 1. Right? So factor forms helps you find what? Vertex form. What do you find from the vertex form? Vertex. What do you find from the standard form? The y-intercept. What do you find from factored form? The zeros. That's why we have 3 different forms. Okay? Now, in scenarios where I have, for example, we're looking at a ball, right? And someone threw the ball in the air, and the ball went and got into the hoop and then fell on the ground. What do these zeros represent? What do the zeros represent, not the y-intercept? It represents when the ball hits the ground, because the ground is your 0, right? Right? Or if you have a company, right, and the company is spending money, but it's making money at the same time, right? Spend money, make money, right? When would you consider the company break even? What does break even mean?
Equal.
That means your cost and your income, right, is equal, right? So that means your profit is how much?
Equals.
What's the profit? How much profit is the company making? 0. That's your break-even point. These are your zeros. Okay? So we're going to look at different different examples of what do I look for when I'm looking for the y-intercept, for the x-intercept, or for my zeros. Okay? Now, an equation in factored form, which is, the factored form is written like this. Y equals a x minus r, x minus s. Okay? This is how we write, this is a general form for the factored form. Okay? Where r and s are your factors. Okay? Tells the location of the zeros. And then we talked about the zeros must be removed from the bracket, so that means my zero is going to be x equals, if I bring this over, it becomes x equals x, and x equals r. So these will be my zeros. Remember when I said, when we did this, we set it equal to 0, and then we brought the, yeah. So when you're solving for your zeros, you're going to set each bracket equal to 0, and then you're going to solve for x. Right? How can you, so the factored form can be converted to standard form by? So if I want to go from factored form to standard form, what do I need to do? Foil or expand. Expand. Right? So foiling process, but it's expand. That's by expand. Okay? How would I expand this? What do I have to do first? I multiply the brackets. I have to foil the brackets. X squared plus x minus 2x minus 2. And then distribute the 3 in. Excellent. So 3 times x squared is 3x squared. 3 times x is 3x. 3 times negative 2 is negative 6x. 3 times negative 2 again is negative 6. And then collect like terms. You guys are rocking this. Yes, you are.
That's like the most sarcastic.
No, I am not kidding. You guys are. Honestly, you are.
No, even she's like, it's not sarcastic, but then what you
I hate this.
it sounded like it.
Okay, are we okay with this? So this is just going back and forth. Remember that we can go back and forth between the different forms. Okay? We can go back and forth. So now that we have one, we have to stick with it. Okay? Okay, so here's what I want you to do. You are going to, I'm going to split you into 3 groups. Okay? 2 groups are going to take the front somewhere, and then the one group is going to take the back board. And you're going to work on the 3 different examples, and then you're going to explain it to us. Yes?